precast, pre-stressed concrete pavement, paving the road of the future. Precast concrete has been used in bridge construction for decades, and today more than 50% of new bridges incorporate precast concrete components. More and more, various elements of these bridges are being fabricated with precast, pre-stressed concrete, as the full range of benefits of prefabrication are understood and applied. This includes the use of precast, pre-stressed concrete panels for the deck. These panels offer a smooth, durable, and quickly constructed structural slab surface. This system also allows for periodic deck replacement when conditions warrant. Today, this concept of using precast panels for bridges is being expanded to highways in a number of imaginative ways. The technique uses existing technology to create major benefits for state and local highway agencies, for the owners and operators of critical facilities such as airports, and hospitals, for paving contractors, and most especially for the traveling public. Indeed, the benefits are so dramatic that this technology is not only considered newsworthy by the general public, but it has created a great deal of interest.
How about prefab freeways made to order?
Caltrans is testing out a new paving technique that's designed to please motorists. Eyewitness News reporter Garvin Thomas has a live report from El Monte.
Philip, let's be honest, highway construction isn't always the most exciting topic, but give us a minute here and I think we'll be able to explain to you why what Caltrans is doing here on the 10 freeway in El Monte is not only interesting, but why it should matter to you as well. What we're talking about is this: they're building a new roadway here using these prefabricated strips of concrete. It's about a foot thick, 8 feet long, 37 feet wide. Now, the ones you're looking at here were just installed last night. And as we show you that process from last night, let me explain why Caltrans is so excited about this technique. First, they say it is faster, about 2 times as fast as laying down roadway the old way. The old way, when they had to pour the concrete right on the roadway, you had to wait a month before you could even drive on it. These new strips, as they go down, they are ready to go the next day. You could actually drive on it the very next day. They say that faster construction time means obviously less delays and less traffic for everybody. I thought you might like that. Not only that, they say this new way uses less materials, which makes it cheaper. And finally, those new materials should last about twice as long as the old stuff.
When we do this kind of construction, they probably won't see this being repaired or done anything to during the rest of their lifetime.
How are precast, pre-stressed concrete pavement panels installed? The basic concept is easy to explain. The existing pavement is removed and the base prepared, providing a stable platform for supporting the panels. A sheet of polyethylene is laid over this base. The sheet reduces friction between the base and the panels, allowing expansion and contraction during post-tensioning. Each section of pavement contains 3 types of panels. All of them are pre-tensioned in the transverse direction, meaning across the roadway width, to reduce bending stresses in the panels during lifting and transportation. The panels also have monostrand ducts cast through them in the short direction, that is, their length, for later post-tensioning. When the panels are in place, post-tensioning strands are fed into the ducts through the pockets in the central stressing panel. They're fed in opposing directions until they reach the joint panels, where they lock into the anchors. The 2 strands are then tensioned against one another, using a monostrand stressing ram and spliced or coupled at this central location. After the post-tensioning is completed, the pockets in the joint panels and the central stressing panels are filled with high-quality concrete. The post-tensioning tendons are then grouted their full length. Finally, any voids beneath the panels are filled by pumping grout beneath the slabs if necessary. The benefits have led the Federal Highway Administration to encourage state departments of transportation to examine the viability and benefits for their areas. Already, projects have been completed in Texas and California.
There's some folks in the Federal Highway Administration that have had some interest in this for years. We've got a concept, we've got an idea, we've investigated it through the feasibility study. Let's try it out. Let's put some precast pavement on the road and let's see how it goes.
More projects, using the components in entirely different and equally exciting ways, are being planned in Iowa, Missouri, Indiana, and yet another in Texas.
The public is demanding so much more from us. They want to have a product and they want it to last, and they don't want to be tied up in traffic. And the benefits that come out of the pre-stressed post-tension pavement sections is that we offer that. We get in, we get out, we give them a quality product, and they don't need to see us again.
What benefits do these states see in precast, pre-stressed concrete paving components?
The speed of construction reflects into faster opening of the travel lanes. It also poses less danger to the construction crews. And one of the biggest benefit is the minimization of the user delay costs.
Highways can be open to traffic as soon as the panels are in place, requiring no extra time for curing. Producing the panels under plant-controlled conditions allows them to achieve the necessary strength prior to placement. This means that the replacement of deteriorated existing pavement can be done at night. Cutting, removing, and replacing the existing roadway pavement can be phased over 2 or more nights to allow the roadway to continue to be used during the day.
One of the challenges we will have in the highway industry is our system is aging now, and we are going to get involved with this rehabilitation and reconstruction mode very quickly. And lots of highways we simply can't close for long periods of time. So accelerated construction is a key for any future improvements to our highway system.
User costs are a key expense for highway construction. Closing and rerouting traffic causes long delays, detours around business districts, and, perhaps most important, added safety concerns for workers and travelers alike.
We want to minimize the fatalities in construction zones. And because we can utilize precasting and precast concrete paving technology, which allows us to do faster construction. So there will be a minimum construction time, which would reflect into fewer accident rates in construction zones.
Another advantage is the system's durability. High-performance pre-stressed concrete ensures that these panels will virtually last a lifetime, even under today's heavier freight loads. The FHWA sees this as a key advantage to the system. Precast concrete manufacturers formulate and produce consistently high-strength concrete mixes under stringent quality controls. They cast and cure their products in a controlled environment, all under the scrutiny of the Pre-Stressed Concrete Institute's Plant Certification Program. Problems that arise with other systems, such as curling, surface strength loss, and inadequate air entrainment, are eliminated. Pre-stressing the panels in the plant significantly improves performance by inducing compressive stresses in the concrete panels. This effectively prevents cracking. This durability not only slashes maintenance costs over the life of the roadway, but significantly cuts user costs through the reduction of repair cycles.
We believe that if this is constructed properly, that the design life of this section will far exceed the 35 years or the 45 years that the original pavement was able to survive out there. So we may well see everything else falling apart around it and needing complete replacement long before we need to do anything to this piece of pavement.
Pre-stressing also provides significantly thinner slab sections. The pre-stressing reduces or even eliminates tensile stresses in the slab, allowing thinner sections to accommodate the same traffic loading. Completed projects in both Texas and California have used sections that were as thin as 8 and 10 inches respectively. These precast, pre-stressed sections can be designed to have a fatigue life equivalent to a 14-inch thick conventional cast-in-place concrete pavement. The thinner sections require less material, which saves costs. They're lighter, allowing easier handling. Being thinner, they can also provide greater clearances beneath underpasses. The thinner slabs also allow in-kind replacement. That means an existing 8-inch pavement can be replaced with an 8-inch precast panel that provides a design life equivalent to a much thicker pavement. By casting and curing the panels in the plant, they are not as susceptible to variable on-site environmental conditions necessary for cast-in-place projects to succeed. So, paving projects can continue even under adverse conditions, extending the construction season.